Welcome to Control 4 Driver Development Essentials. My name is Peter Cosenza. In this video, we will walk you through the steps required to create a Control 4 driver for a blind or shade motor. In this video, we'll use two tools delivered by Control 4 to assist with the driver creation. The first is Driver Editor version 3.01. This latest version of Driver Editor is a driver development environment that provides a graphical interface for the creation and modification of C4Z files. It is important to understand that Driver Editor 3.0 and all subsequent Driver Editor releases are compatible with C4Z files only. If you are new to C4Z files, we'll discuss them in the beginning of this video. The second tool we'll use is Control 4's latest blind driver template. Control 4 is currently in the process of delivering driver templates for many of its more heavily used proxies. Driver templates are delivered with Driver Editor. When a template is selected and loaded into the Driver Editor environment, it offers a powerful development scenario that can reduce development time as well as improve code quality. In this video, we'll use a template specifically designed to help create blind and shade control drivers. In viewing this video, and all videos found in the T201 series, it is expected that you be familiar with the architectural and development concepts outlined in the driver development training modules. This includes the 201, 301, 401, and T101 video series. You may find it useful to review the information offered in those training modules before proceeding to develop template-based C4Z files. Before we begin creating a driver for blind control, it might be useful to briefly discuss C4Z files. Beginning with Operating System 2.6.0, Control 4 has changed the file structure previously used to support device drivers. Up until 2.6.0, device drivers were contained within a single file using the extension of C4i, or drivername.c4i. The release of 2.6.0 marked a significant change to this model with the introduction of the C4Z file structure, or drivername.c4z. A C4Z file provides all of the contents that the C4i file previously did. However, it offers some significant features and advantages that its predecessor did not. At its most basic level, a C4Z file is a zip file. It contains numerous folders and files which, when encapsulated inside a C4Z file, represent a device driver. The modularity within a C4Z file enables a far more organized and structured approach to device driver architecture. It also provides the ability to include many related objects within the confines of the driver in an organized manner. These objects include items such as graphics and icon directories to support custom user interfaces which can run on Navigator. A C4Z file also contains one or more Lua files, which contain all of the driver's Lua code. Control 4 driver templates take advantage of the C4Z structure by delivering libraries of commonly used Lua functionality. These can now reside in one directory location and can be easily referenced. A C4Z file also has its own XML file, which separates the XML portion of a driver from the Lua code. Additionally, rich text documentation can be included in the C4Z to support a far superior user assistance model. Before we move into driver development, it's important to obtain the latest protocol document from the device's manufacturer of the blind motor for which you wish to create a driver. It will provide you with the device's communication syntax and notifications it will send to Control 4's blind proxy. With this information in hand, let's take a look at the Driver Editor environment and Control 4's blind driver development template and how they'll play a role in your blind driver development efforts. From within the Driver Editor toolbar, we'll select File and hold our mouse over the New menu option. Here we are presented with several choices. In this demonstration, we're going to create a new driver project, or C4Z file, based on an existing template. So we'll select the Driver Project from Template option. When we do so, we can see the Blind Proxy template. Selecting it loads the template into the driver editor environment. At this point, it's worth explaining a driver editor construct that is important to understand. Driver Editor 3.0 views C4Z files as a project. When a C4Z file is loaded into its environment, Driver Editor organizes the C4Z into a structured project and displays it in the Driver Project window. Due to the organized structure of a C4Z file, it's easier to consider our driver as a project while working within the Driver Editor 3.0 environment. This is also a good time to discuss where Control4 driver templates reside on your system. Driver templates are delivered by Control4 through the Driver Editor development environment and will always reside in the following directory: C, Program Files, Control4, Driver Editor 3.01, Templates. You will also find a driver template directory in this location: C, Users, Username, Documents, Control4, Driver Templates. This directory is created for you to store driver templates that you have customized or created on your own. It is important to keep these templates separate from the Control4 supply templates, as the Driver Editor Templates directory is overwritten upon an update of Driver Editor. Along with the templates overview documentation, you'll also notice the Driver Project area of the screen. Here is where we can see the project framework that is provided through the Blind template. At first glance, it may seem like there are lots of files and directories. However, it's actually numerous Lua files organized by purpose. You'll note that some of them are in libraries as well. Here is our driver's XML file and also driver documentation in a rich text file. If you are familiar with the C4I file structure, you'll remember that all of this would have previously resided at one level within the confines of a single C4I file. If you want to open one of the Lua files in the project, simply click on it and its contents are displayed in Driver Editor's editing window. For example, let's open the project's main driver.lua file. This file is significant as it contains all of the require statements for our driver, as well as the initialization code that is executed when our driver loads. We can also see our driver's XML content in the window by opening the driver.xml file. When we double-click the file, we can see the high-level XML in the driver configuration window. Many of our driver's XML information is edited by double-clicking on any of the top-level elements. This displays Driver Editor's XML editing screen. Here, numerous XML entries can be modified and easily saved in our project. The more complex XML elements can also be opened and edited in the driver configuration screen. For example, if we open the proxy's XML entry, we can see a high-level view of its contents. Double-clicking on the proxy value will display the proxy editing screen where changes can be made and saved into our project. You will find that the UI in Driver Editor presents XML based on the data types and amounts of data that a particular element contains. For example, if we go into Capabilities and double-click on the Level Discrete Control element, the Driver Editor screen will display a window to view or edit any of the capabilities. Let's go back into Driver Project and look at one more file. Notice that I can toggle between Driver Configuration and Driver Project by using the tabs at the bottom of the Driver Editor screen. Here is the documentation.rtf file. Double-clicking on the file opens an editing screen which supports rich text formatting. Font assignment, images, and hyperlinks are all supported in this area. This provides you with an excellent opportunity to deliver quality driver documentation to integrators who are using your driver in commercial or residential systems. Now, let's begin to modify this template and turn it into a publishable C4Z file which supports our blind controller. In this section of the video, we'll show you examples of each of the development steps to complete the driver. These include handling proxy notifications from the blind proxy to the Control4 UI, handling proxy commands from the Control4 UI to the blind proxy, updating the XML for the driver, adding documentation to support our driver, building the driver in Driver Editor, validating the driver in Driver Editor, and finally, publishing the finished C4Z file. To start, let's look at handling data flow coming from the blinds to the Control4 user interface. We'll call these data messages notifications. All notifications sent from the blinds need to be parsed into a format that the Control4 blind proxy can understand, so they can be handled correctly by our driver. Because we have the blind controller's protocol documentation, we have a good idea of what these messages will be and how they'll be formatted. Your driver receives communication from the blinds through the device messages.lua file, specifically inside of the getMessage function. The communication is broken into logical chunks and sent to the handleMessage function. HandleMessage is responsible for taking the communication block given to it by getMessage and identifying it into a unique function and parameters. Once this is done, those pieces are then sent to dispatchMessage, where the appropriate driver developer created devMessage function is called to issue the correct calls to update the state information of the system. Also in this file, we can see that all of the blind proxy notification handler function calls are provided. Keep in mind, there is no need for us to edit any of these function calls. Rather, these notifications will be called after we parse the message from the device and create the new function. Our new function will call the appropriate predefined notification, which is then sent to the proxy using the Send-to-Proxy API. Let's take a step back and see how this happens. Once again, all parsing of messages from the blinds happens inside the deviceMessage.lua file. If we open the file, we can see that sample functions have been included. For example, here is one named devmsg.moving. This function is called when a blind is in motion. Your job as a driver developer is to parse the incoming messages from the blinds into a format that can be sent to the blind proxy and then subsequently notify the proxy that the blind is moving. Keep in mind that if your blind motor sends multiple messages within one response string, each message will need to be parsed into a single function for processing inside of getMessage and then sent to handleMessage in the deviceMessages.lua file. For example, let's consider a message that comes from the blind motor when the blind is stopped. The incoming message looks like this: STP:50. Without modification, this means nothing to Control4's blind proxy. We need to parse this incoming message into a name-value pair, with the name being the command from the blind motor and the value being its parameter. Once the data is correctly parsed into a name-value pair, we'll use the devmsg.stopped function here to send the value of the level indicating the blind's current position to the blind proxy so that it can be handled by our driver. The proxy class defined in the blind proxy class.lua file provides a template API or group of functions that can be called by the devmessage.stopped function. These APIs are recognizable by the blind proxy and can pass the blind status data onto our touchscreens in the project. The names of these API functions begins with dev_. For example, here is the function for handling the stopped blind state. It's called dev_. stopped, and it takes a value for the level indicating the blind's current position. Knowing this, we need to go back into the device-message.lua file and modify the dev-message.stopped function to look like this. Once we have handled all of the messages that are sent by the blind and require being sent up to the UI in this manner, we can move on to handling proxy commands. Now, let's change direction and take a look at communication flow coming from the Control4 UI to the blinds. When we refer to Control4 UI, we're talking about the initiation of a blind-based message being sent from any device running Navigator or Composer Pro's control. For example, this could be a T3 touchscreen. We call these messages proxy commands. When a message is initiated, it first calls Control4's blind proxy. The proxy then calls into the Control4 API received from proxy, which, in turn, calls into the blind proxy commands.lua file using the PRX CMD command table structure. Blind proxy commands.lua is a template file that receives the command from the blind proxy and handles it for you, the driver developer, by modifying its format as well as its parameters. For example, calls, the blind proxy commands.lua file then calls into the blind proxy class.lua file. This is a template file that stores device-specific data within the driver template. It receives the modified command and extracts its tparams table into one or many individual parameter elements for you. In doing so, it also modifies the format of the command further. For example, calls. This modified version of the command is then delivered to the proxy commands.lua file. Here is where you, the driver developer, needs to receive the command and its parameters, modify them in a manner that is valid for your blind motor, and subsequently send the command to the blind motor via its designated communication method. Now, let's take a look at an example of the functions that are included in the proxy commands.lua file. In doing so, you will see how the template keeps the actual function code in small, easy-to-read code blocks. Here we see the setLevelTarget function as it is delivered in the template. You will notice that the to-do line indicates that you need to provide the values used by your blind motor for setting the blinds to a certain level. A value needs to be placed within the quotes for the local variable named command, which represents the blind's protocol command for blind level. By referencing our device's protocol documentation, we know that the following string is assigned for moving a blind to a defined level. BLD level equals 50. This string is entered between the quotes for the local variable named command. Our code for the setLevelTarget function now looks like this. You will need to enter the correct protocol strings for any functionality that your blind supports, such as stop or level toggle. Once we have handled all of the proxy commands, the Lua development work for our driver is complete. Now, let's look at the XML portion of our driver. As we stated earlier, there's only one XML file in our project, driver.xml. Note that the driver.xml file name cannot be changed in the template, as Driver Editor expects a driver.xml file to be present when it builds our C4Z file. That file is edited through the driver project screen on the right-hand side of Driver Editor. The example blinds for which we'll be creating a driver in this video is the Acme Blind Controller. So we'll change the manufacturer and model fields to reflect that. Next, we'll name our driver. This entry is important as it will be displayed in places where users will be looking for our driver. A driver name should be descriptive and informative. We'll name this driver Acme Blind Control. We'll leave the creator value unchanged for our purposes, but this entry could be a developer name or a company name. Next is the version field. Since this is our first iteration of this driver, we'll leave the version at 1. However, you can start your versioning as you see fit as long as the version numbers used are integers. We can also update the created entry. This is useful as it provides a date stamp when our driver development was initiated. You can modify the time and date elements by highlighting each and using the arrow buttons. You can also set the field to the current date and time by clicking on the plus icon. The modified field functions similarly to the created entry and offers you a way to assign a time and date stamp to future driver modifications. We'll set our modified value the same as our created entry. You can also set the modified date element on a system-wide level under the Tools Options menu. Select dates and you are presented with 3 choices for how the modified date field will be populated: manually, as we have just demonstrated. Upon saving a driver, the modified field will be updated, or you can choose to have the field updated upon publishing the driver. Those are all of the changes we need to make to the main XML page for our driver. All of the remaining values are set correctly by default for us from the blind proxy template. At this point, we've configured all of the high-level XML information for our driver. Now, we'll take a quick look at proxies. We verify that the blind proxy is already added for us, so there is nothing more we need to do here. Just below proxies, we can see the capabilities. It's worth mentioning how significant blind driver capabilities and their respective settings are to your driver development efforts. For example, let's take a look at the driver handles toggle capability. This is a Boolean capability which defaults to false. When false, the Control4 blind proxy will handle toggling the blind movement by sending a command called setLevelTarget to your driver. Your driver will need to be able to handle the setLevelTarget command in the manner we discussed in the proxy command section of this video. However, if driver handles toggle is set to true, the proxy sends a level toggle command to your driver, so your driver can handle toggling the blind however you see fit. This approach would require that your driver contain all of the necessary logic for handling toggling the blind natively. As you can see, capability settings are important and need to be considered in advance of your development efforts. Next, we'll take a look at the Connections tab. You will notice that the template has 4 pre-populated connections, one for the blind proxy, and one each for serial, IR, and network connections. Also, if we open up the Classes section, we can see that the correct class name is already provided. The template supplies all of the necessary connection information for our driver by default. Finally, we'll include some documentation with our driver, which will help integrators with setting up and configuring the blind controller. To do that, we'll open the documentation.rtf file and either copy pre-existing content into it or create it right inside the window. This content will be displayed in Composer Pro under the Properties Documentation area for our driver. At this point, we've reviewed and modified all of the key components of our driver project. Driver Editor provides several tools for us to finalize the project and eventually publish it as a working C4Z file. The first step in this process is building the C4Z project file that we've been modifying. The build process does several things. First, it saves all of the files in the project. Then it creates a C4Z file from the list of files found inside the driver editor under our C4Z proj file. To build our project, we'll open the Project tab from the toolbar and select the Build option. Alternately, you can use the shortcut key of F6. When the build of the project is complete, the output window is updated with the results. The next step in our process is to validate our newly created C4Z file. It is important to understand that a project must be built before it is validated. If you select Validate before building, Driver Editor will force a build of the C4Z proj file to create a C4Z and then perform the validation. The validation step is useful as it leverages a set of generic tests applied by Control4 and delivered within Driver Editor, which reviews the driver XML file for correct XML structure and valid content. It also compiles all of the Lua files and validates them for correct syntax. To validate our C4Z file, once again open the Project tab from the toolbar and select Validate. F7 will also initiate the validation process. Before validation begins, you can set the verbosity level of the validation process as well as the level at which logging will be displayed in the output window once validation has completed. Verbosity level gives a listing of the tests that were performed against our driver as well as their status of pass or fail. Let's select the Most option here, as this setting will provide us with additional information in the event that a test fails. We'll select Debug Logging Level, as we'd like to see any log content that will help us figure out where an issue may be within our driver. Clicking the Validate button begins the process. Here we can see the log file contents of our C4Z validation. The log shows us all of the tests which were run against our XML and Lua code, as well as the results. Using Driver Editor, we have built the C4Z driver from our C4Z proj file. Next, we validated the C4Z for invalid content. Now we are ready to publish our finished blind controller driver. The Publish function in Driver Editor is useful as it places the finished C4Z file in a designated area which can be devoted to completed drivers. You can designate this directory by clicking on Tools from the Driver Editor toolbar. Select Options followed by Workspace. Here you can designate a target directory for your driver project directory. This is where all your driver projects are kept before they become C4Z files. The Build directory allows you to designate a place where your drivers can be built and saved as you make changes to the driver's code. Finally, the Publish directory is where your completed publishable drivers will reside. Having different Publish and Build directories allows you to make changes to a driver that is maintained in the Build directory while still providing a published version of that same driver. This concludes the template-based blind driver development video. We hope that you found the information presented here informative and helpful in assisting you with developing Control4 drivers for blinds and shades.